All right, hey guys, welcome to week one, which is technically week two because we start at week zero. This week we're going to dedicate to data and variables, and we're going to get into another few topics, but right now let's just focus on data and variables. This week is pretty important because we start to get into some of the underpinnings, the foundational knowledge that we need to know to properly program in Python. And there's some very fundamental concepts that if we take the time now in this week to try to understand and work through, even though they're kind of esoteric and hard to wrap our heads around, it's going to serve us really well for the next 17 weeks. We're going to start right now with data and variables. I'm also going to do something a little different. Instead of doing a traditionally long video that starts to get into like the 30, 45 minute, even hour long, I'm going to try and take a lecture and I'm going to snap that guy in chunks. I want to stick to around 10 to 15 minutes. This first one might be a little bit longer. Let's say 15 minutes. And then the successive ones will be shorter, 10 minutes, because the stuff is a little, I don't want to say dense, it's just different, especially if you're not a programmer. I want you to be able to have some time to soak in this and kind of understand it and wrap your head around it because it doesn't make immediate sense. Anyway, that being said, that's my preface to this lecture. Let's talk about what we're going to be getting into and dig in. The lecture agenda is going to be talking about data. We're going to talk about data versus information, saving data and recalling data in theory, and we're going to cut it off here. And then the next video will be all about variables, and we'll talk about what those are, and some terms that we need to know when we're talking with our programmer friends and colleagues. And we're also going to kick some code. So we're going to figure out how to instantiate, how to create a variable, how to assign data to a variable, all that fun stuff. And then we'll have a final video which might be a little bit longer, and we're going to talk about the actual types of data that you come across, not just in Python, but in programming languages in general. And I think it'll start to kind of make sense once we have these fundamental like these fundamental concepts to start playing around with and working with in our toolbox. It'll make the next part, the next week, much easier to understand. So let's get into it. First things first, what is data? If this were to show up on a test, I would expect you to know that there is a difference between data and information. Wink, wink, nudge, nudge. What would I call data? I'd say it's raw. It's unanalyzed, unorganized, and for the most part, unrelated, uninterrupted entities of dot dot dot. I don't want to say information. I don't want to say data and use a term in it, but we'll start to understand how this starts to coalesce a little bit more in a second. Where does the term come from? It comes from the Latin word datum, which means something given, and this should make sense as we get into it a little bit more. And we should also know that there are many forms of data. Some of this might seem contradictory when we start to understand what information is, but we're going to work with it a little more over the course of this lecture. Hopefully it makes sense. So images, letters, character sets, some graphics, streams and feeds, I say this with a caveat, would be considered data. And then of course, how do we measure data? We're starting to try to pull this into a concept that's tangible, and we can work up the scale with the prefixes. It starts with bits, right? We're looking at basically in the digital world ones and zeros, and then bytes, which is 8 bits, and then we get our prefix game going. So we got start with bytes, and then we go kilobytes and megabytes and gigabytes, terabytes, petabytes, yottabytes, all these large amounts of data. Um, if we can sum all this stuff up really quickly, just think of data as like a digital stream of consciousness. Yeah, that's good. So it's just kind of like spewing representation. Okay. And then how does this work? Like, let's say we have a data source, a database, and we want to get our Netflix and chill on. I don't know if the kids are still saying that. We have a stream of information. And even though the data coming might be organized or related at the production point or the origin point, let's say database, and then it comes together in our browser or our TV or whatever we're watching it on, that in the process of coming across isn't organized. It's actually the exact opposite. It's almost chaos, and we're going to talk about that a little bit more. So to help drive this point about what data is home, let's flip the coin a little bit and we'll talk about what information is. And when we juxtapose these, maybe they'll make more sense. All right, so information. What is information? What's the difference between information and data? It's Information is processed data. Consider accurate, um, understandable, relevant, timely, systematically like tied together. You start to have this stream of consciousness that comes out in digital format, and we start to organize, and then it becomes information, right? Um, Information derived from the French verb informer, meaning to inform. So that makes sense when we start to consider that information is data plus meaning. We have this stream of conscious, and then we start to add meaning to it, and it makes sense and it becomes relevant somehow. It enhances knowledge and adds meaning to the data as we start to put these facets on it, and then it becomes information. So if you would consider this stream of bits, this data consciousness blah coming at you, and then we start to snip it up into little bits, right? And then we put a timestamp on it maybe, and then we put it in a nice little package or some kind of organizational unit. We'll tag it, maybe metadata, data about the data, right? Then we put it in a box and store it in memory somewhere so it becomes retrievable. And we have all these different ties to data, which makes it more robust, makes it informed, and then we can put it in a database someplace so it's retrievable. And that's what makes it information. I also want to point this out here really quickly because I get this question a lot. I want to go back to measuring data, and we're talking about bits versus bytes. So what's the difference between bits versus bytes? We use bytes and those prefixes thereof of bytes to talk about storing data. Bits is used when we're measuring the transferal of data. And there's a rationale why. I can jump on the screen to show you really quick. Okay, so at the application layer, that's where our data gets produced, right? It's coming out of applications, or at least it's heading into applications, depending on which direction the flow is happening. But as we go down the layer, the layers in the OSI model, let's see, we start to append or encapsulate our data with additional information, additional tenants that go onto it. So, our transport layer, we start to throw on a header here. Ah, that's really thick. I'll try to use smaller brushes and for the future portions, right? Let's pick a different color. And then let's say like when we get to the IP layer, the internet layer, we start to throw an IP header on there. And then we get to the link layer before the data goes, over actual medium. We throw on, let's see, a frame header. I think goes over here. And then we want I wouldn't call it frame footer, but the tail, or we'll just call it footer. So our data is right here. And all of these sections that get appended or encapsulated are bits of information. It's not huge chunks. It's literally, we're getting down to ones and zeros at this point. So I should probably start throwing some zeros on here. When your ISP, your internet service provider, is talking about how much information is getting transferred, you're not getting gigabytes. We're not getting these coherent chunks of data that's streaming through, through your wall to all your devices. You're actually getting these discrete bits. It's this big stream of consciousness that's getting broken down into smaller sections, these with these packets or these data frames, whatever the encapsulation method is, depending on the layer of the stack. And that's what's coming across. So that's why we have bits versus bytes. We're getting bits of information being transferred. We're storing it as it comes back together as a collective whole, and we're storing that into bytes or gigabytes or megabytes or whatever. So that might help explain the difference when people talk about bytes versus bits. Bits is usually intended for transferring information or transferring data. Bytes is used for storage. Okay, so we got that out of the way. Groovy. All right, so we're back to talking about the concept of information, data being a huge stream. We chop it up, we make it manageable as it goes through the OSI stack or as we're getting ready to store it, timestamp it, we make it organized, we tag it, we assign it a memory location, we put it in a reservoir, some kind of repository to be, taken back later, and that's information. It's not willy-nilly ones and zeros. Now it's nice, neat with a bow on it so it can be retrieved, cataloged, or otherwise used. And I want you to kind of understand and think about that, the concept versus data and information, because a lot of what we're going to be doing while we program over the course of this term is we're going to have to discern what we're getting and what we're trying to push out. Are we trying to push out data or information and what we're working with? All right. So let me give you a quick example, and then we're done. We're done beating a dead horse. All right. So data, right? Let's say this number. It could be any number. 23100. That doesn't mean anything. Doesn't have any coherent value to us, right? There's no logical anything about this. Well, if we add something onto it, oh, we add a dollar sign and a comma. Okay, so that still doesn't mean anything, but I'll call it data plus. That's 23,100. That's cool, fantastic. There's an extra piece of data, and then we'll get into information. An RV down payment to the lendee Mr. Jones that was made 2/13/2021 is $23,100. That's information. That's something conceptual. That's something that we've added value and meaning to. That's the difference between information vice data. So going back to the top, irrelevant data, just a random number. Data plus, type casted data. We know what type of data it is, which is something we'll talk about when we get into data types later. And then at the very end, when we've got all of our ducks in a row, we've actually got qualified information. All right. So last thoughts on information or data before we end this video. Information factors. Information has to have at least some of these, but hopefully all of these, right? It's got to have accuracy. It's got to have some modicum of understandability. We need to know what we're looking at, and it needs to be relevant to whatever the situation or the scenario that we're using it in, and it's got to be current. It's got to have some currency to it. It's got to be up to date. We're talking about the stages of processing or using information, right? There's an input stage. Data has to be inserted somehow, some way. It has to be processed. We need to understand the rationale in which we're going to be working with it and routing it through a program in Python, for example, right? The alteration and the manipulation of data, right? Then there's the output, so that's the results. That's the generation or regeneration that we're going to be providing with our programs, and usually it's for input for something else. And then there's the storage of data, and that's where we're going to put it in a repository so that it's retrievable and we can get to it when we need it. Those would be the 4 stages of processing for data and hand holding it with information. The factors of information being worthwhile information are that it's accurate, understandable, it's relevant, and then of course that it's current, it's up to date. All right, so that's, I think, where we're going to stop it, talking about data vice information, and I'll see you in the next video where we start talking about variables. We start putting these concepts into something that we can use in Python. All right, I'll see you then. Thanks.